We got a what?
We got an I.
We've got an I.
Yeah. We set it equal to negative or the x squared plus
I don't know what
6
you're talking
equal to 0.
Yeah.
I.
I don't know what you're talking about. But anyways, so first one, what's the domain? All real numbers, I like how that starts. And then x cannot equal 0. What's my vertical asymptote? X equals 0. Horizontal asymptote. There should be none because the degree on the top is 3. The degree on the bottom is 1. Top is bigger. That's a none case. Oops, I almost wrote the word none as in church none. I was saying in my brain, if I could only draw a none, you know. Okay. Domain in the next one. MSA, what are you thinking? How's it start? How's it start? Domain, how does it always start? All real numbers. Is there any conditions, restrictions, thingy where that's going to make that denominator be 0? Negative 3? What's negative 3 squared?
Oh, wait, never mind. So, it's all real numbers.
It's just all real numbers.
It's all real numbers. Yeah, I knew that.
Wait, but can't you flip something in x squared equal negative?
Not real.
Not real? Oh, okay.
You can put an imaginary number in there, but that's not real. Which is why it starts with all real numbers. You know what I mean?
Whoa.
I know. So then what's my vertical asymptote?
None.
None. There isn't any.
I like that. That's nice.
Horizontal asymptote.
Y equals 2.
Y equals 2. Okay? Yeah, buddy? Of those three, for number 11, number 12, and number 13, I want you to find me all of the asymptotes for all three of those. Means you got to find the horizontal and you got to find the vertical asymptotes. All right, first one. What's the asymptotes in the first one?
Vertical asymptote is none.
There's so that's there is one there. Okay.
And then the horizontal asymptote is y equals 0. Or did I do that wrong?
Do we agree with no vertical asymptote? Horizontal asymptote is y equals 0. Yeah. Okay. Second one. What are the asymptotes?
Vertical asymptote is still none.
Still none.
And the
Hold
horizontal.
on, just wait.
How come it can't be vertical asymptote x equals 0?
Because put in 0. What do you get?
Because 0 squared is 0
Times 3
0
plus 1. Yeah. That neat old math teacher putting that plus 1 on there for you.
Yeah.
Yep. So second one. What you got, Claire? Is my horizontal asymptote? Do we agree with that one? Yeah? What about the third one?
None. Both none.
There's no asymptotes on that one at all. Okay? With me? Alright. Now. Next, 3 things. Today we're going to do 3 things. We did one thing on Monday. Crabby day. We did one thing on Tuesday. More crabby day. Today we're doing 3 things. How crabby do you think I'm going to be today? Are you
Not crabby at all, because you're in a good mood right now.
I was in a good mood all week.
Crabby today was
I was in a good mood all week. I don't know what you guys are.
The mood has coffee is not directed at you.
I know know your cough was not directed at me. Your cough was directed at him.
Yeah.
I know. I'm fully aware. I'm fully aware that you wouldn't flip me off. She gave you one of these.
Okay.
That's all been recorded.
That's some great audio files right there of me coughing twice.
Yeah. But you did say she flipped him off.
But they don't know that it was during her cough. His wheel is spinning right now. That hamster's running a marathon right now. Alright, so step number 3. Okay? So step 1 was what?
Domain.
Find the domain and the vertical asymptotes. Step number 2 was what? Find the horizontal asymptote. Top is bigger, none. Bottom is bigger, y equals 0. Same,
Divide.
a over b, coefficients. Okay? Alright, fantastic. Step number 3, find the yint. Not the yeet. Find the yint. Okay? I know. Okay? So, what is the y-intercept? Again, I'm making you think. Abstractly, what is the y-intercept?
Where the graph crosses the y-axis.
Where the graph crosses the y-axis. And the y-axis is the vertical one, right? Okay? So, what is true about every single point on the y-axis?
X equals 0.
X equals 0. So this is where x is equal to 0, or where it crosses the y-axis. Now, how many y-intercepts can we have? One, because we're talking about functions here. So if we had 2, it wouldn't be a function. It would fail the vertical line test. So we can only have 1. How do I find it? So I plug in 0 for x. So we're basically finding f of 0. So you're going to plug 0 in for x. So I believe I go with green for y-intercept. So my y-intercept, or the yint, as we like to call it, is going to be 0, comma, some number. In point form, because it's a point. Vertical asymptotes are in line form because they're lines. Horizontal asymptotes are in line form because they're lines. Y-intercept a point. So it's got to be in point. Okay. So that's step number 3. Handle? Okay. Step number 4. Now what do you think we're going to find? The x-intercept, or the cint.
X makes a z.
X makes a z?
Yeah.
Well, it's not. That's a z-intercept because there's a z-axis too.
Oh, well.
Are you for real?
Yeah. Huh. 3-dimensional. When you go 3-dimensional, x and y are left. X is left and right, y is, and z is coming out at you. Z's coming out. Yep. Okay?
Sint. I don't think X's make a S sound. Or yeah.
Xylophone?
Yeah, so it definitely makes a Z.
Whatever. Here we are debating what sound X makes. Right? So, what is the X intercept?
When you replace f of x for 0.
No. It's when y equals 0. Or where your function is equal to 0. It's where what?
Replace the f of x for 0.
It's where what? What? Where my function crosses the x-axis. Okay? How many x-intercepts can there be?
Depends on the gradient.
Many. Depends on what we're dealing with here, right? Now, little side note action here for you. If A divided by B is equal to 0, what must be true? Wouldn't that be 1? No. So, if A divided by B is equal to 0, what has to be true? A has to be 0. Not B, because then we'd be dividing by 0, right? A has to be 0. So, my question to you is this. How do we find x-intercepts?
Put the numerator equal to 0.
Set the numerator equal to 0. Okay. So, those, I gotta think now. Those are actually purple. Yep. They are also points, but those points are some number, comma, 0. Okay. Now, Nick, are you ready?
Mm-hmm.
Because what do you think the next step is going to be?
5.
Step 5?
Yeah.
No.
Wait, what?
Step 5 is great.
We're going to go to step 7.
You actually got us. That's going to be so screwed up, though.
What? You're not ready for steps 5 and 6 yet.
No, I'm ready.
You're not ready.
But my notes are going to be screwed up.
That's right. I'll fix them.
Just fix them.
Yep.
I trust you.
There will be a day when we'll have all the steps in order. Okay? So step 7 says you're going to find other points on your graph using a T-chart. Okay? And I'll show you what I mean by that when we graph. Okay? All right? specifically designed this graphing paper, and then we just used it beforehand too, but I specifically designed this graphing paper for this unit so that you have space to work and space to graph. Okay? So preferably start, have one graph by the work associated with it. Okay? So our first graph without a calculator. And in fact, we're not going to use graphing calculators this entire section, or this entire chapter. Okay? Right? So, use our steps. Then state the asymptotal, and I spelled that wrong though. There should be an E in there. Asymptotial. And end behavior. But again, I'll show you a shortcut for those. Okay? Right?
Thank you.
Alright, so step number 1 is what?
Domain.
Find the domain and the vertical asymptotes. What is the domain of this function?
All real numbers, but x cannot equal -1.
Do we agree with all real numbers, but x cannot equal -1? Yes? 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 Yes. Which means their vertical asymptote is what?
X equals 1. Oh, yeah.
X equals -1. Okay? Now, refresh my memory. I'm going to go to the graph now. How does my vertical asymptote get on there?
Dotted.
Dashed line. Okay? Dashed line at x equals -1.
I'm guessing we need straight ledges too.
Well, if you can't follow a straight line,
Then yeah.
yeah. Okay? Alright? Okay? So that, ladies and gentlemen, is step number 1. Now, we go to step number 2. Step number 2 says, find your horizontal asymptote. Degree of the numerator, 1. Degree of the denominator, 1. They are the same. So my horizontal asymptote is y equals
2 over 1.
2. So y equals 2. Refresh my memory. How does that go on our graph, Lau? Yeah. Might want to wake up. How does it go on the graph? Dashed line. Okay? Right?
Yeah.
Okay. Step number 3. Bless you. Step number 3 was what? Find the y-intercept or find the yint. So that is, I need to find f of 0. So that's going to be 2 times 0 over 0 plus 1. 2 times 0 is 0. 0 plus 1 is 1. 0 divided by 1 is 0. So what is my yint?
0.
No.
0.
0, comma 0. Because it's a point.
I get to finish the comma 0.
You stopped and we're moving on to the next sentence.
I was saying 0, and then I had to process it, and it could process it.
So that's this point right there.
Dude, I already know how the graph's gonna end.
What's step number 4?
Find the yint. Oh, yeah.
how do I find the x-intercept?
Put 0.
What's the numerator? So that's 2, oops, wrong color. Whoa, whoa. So that's 2x equals 0. So that's x equals 0. So my x-intercept is also 0, comma, 0. So I'll make my point. Okay?
Yeah.
So that's my 4 steps. Now, for step number 7, find more points because I only have 1 point on my graph. Okay? I need some more. So what I recommend, and again, this is me, I've done this once or twice, is I would make a mini T-chart for that section of my graph, the right side of my vertical asymptote, and I would make a mini T-chart for the left side of my vertical asymptote. If I have 2 vertical asymptotes, I would make 3 mini T-charts. If I have 4 vertical asymptotes, I'd make 5 mini T-charts. 1 for each section. Okay? Alright? See how it's divided into 2 parts?
Uh-huh.
1 for each part.
Oh, I thought you went 1, 2, 3, 5. I thought you did 4.
I did. Okay. So, our function again was 2x over x plus 1. Okay? So, pick me a number on the right side of -1.
0.
We already did 0.
1.
Because we already got it. You know what I mean?
Yeah.
It's right there. It's our intercepts. So we don't need to do 0. So let's go with something, we could go 1. Okay. So let's do 1. 2 times 1. 2. 1 plus 1. 2. So I've got 2 over 2, which is 1. Okay. Now let's go 4. Something farther out there.
Oh, no.
2 times 4. 8. 4 plus 1. 5. 8 fifths. That's approximately what? 1.6? Okay. So that means I go through this point here and 1, 2, 3, 4, 1.6. Agree with that?
Yeah.
Okay. Now let's come to the other side. Give me a point that is on the left side of -1.
-2.
-2 times 2. -4. -2 plus 1.
-1.
-1. -2 plus, yeah, okay. -4 divided by -1. Positive 4. Okay. Now let's go even farther out. -8. I couldn't hear what you said, Macy. Okay. -8 times 2. -16. -8 plus 1. -16 divided by -7. Positive 2.3-ish, let's say. Okay. With me. So, -2, 4 is right there. -8. 1, 2, 3, 4, 5, 6, 7, 8. 2.3. With me? Do I have enough points to draw my graph?
Yes.
Fantastic. Let's draw it in. So we've got here. And we've got here. Not only can you tell the end behavior, but you can also tell the asymptotal behavior just from the picture. This is saying over here that as x goes to negative infinity, our function is going to 2 from above. This up here is saying that as x approaches negative 1 from the left, our function is going to positive infinity. This over here is saying that as x is going to positive infinity, our function is going to 2 from below. This down here is saying as x is approaching negative 1 from the right, our function is going to negative infinity. Yesterday I promised you that after you graph them, you will be able to do end and asymptotal behavior in 30 seconds. I'm pretty sure we just did it in 14. Huh? Graph it. Spot check. You should have a domain of all real numbers, but x cannot equal plus or minus 2. Which means you should have vertical asymptotes at x equals positive 2 and x equals negative 2. Yes, huh? You should have a horizontal asymptote at y equals negative 2 because it's same over same. Yes, huh? You should have a y-intercept at 0, 0. Yes? Negative 2x squared equals 0. So x squared equals 0. So x is equal to 0. Gives me an x-intercept at the origin also. Correct? But really, it's a double, right? So that means double roots, what do we remember about double roots? It's a kiss, right? It comes down, it kisses, and then it goes up. Nick, here, how many sections of my graph do I have? 3. So I need to make 3 t-charts. Okay? So I would make a t-chart over here. I would make one in there, and I would make another one over here. Okay? So my function again was negative 2x squared over x squared minus 4. So something over, so I'm going to go 3 and 10, we'll say. 3 squared is 9 times negative 2 is negative 18. 9 minus 4 is 5. So that is negative 3.6-ish. 3.6 in there. 10 squared is 100 times negative 2 is negative 200. 10 squared is 100 minus 4 is 96. That's a little bit more than negative 2. Positive 1 in here is going to be negative 2 over negative 3. That's 2/3. Negative 1 in here is going to be negative 2 over negative 3, which is 2/3. Again, because it was a double, it has to come down and kiss it. Negative 3 over here, going to be exactly the same as positive 3 because I'm squaring everything. Negative 10, going to be the same because I'm squaring everything. So my graph looks like that. Agree? Now, it said give and didn't ask the total behavior, right? Yeah. But how long is this one going to take us? A little bit longer. Because there's 2 more. Right? Okay. So, out here, what is this saying? Negative infinity. Our function f of x approaches negative 2 from below. Over here, this is saying as x approaches positive infinity, our function approaches negative 2 from below again. Yesterday, I believe, Nick, you asked the question about, if this one's from below, this one's got to be from above.
Oh, yeah.
Here's another example of where they both are from below. Okay? So that's my 2 end behaviors. As x approaches negative 2 from the left, our function goes to negative infinity. As x approaches negative 2 from the right, our function goes to positive infinity. as x approaches 2 from the left, our function goes to positive infinity. As x approaches positive 2 from the right, our function goes to negative infinity. Yeah, buddy? You want to do one more?
Yes.
Well, if I told you no.
We would still do it.
Okay.
Because apparently I'm crabby.
What's the other option?
The other option is you do this one.
So there's no other option than doing Z.
What day is the final?
January.
Oh, around then? Okay. I was going to say, I don't even know what day the final is yet.
Sure, he knows the answers to it.
Domain here is all real numbers, but
X cannot equal 3/5.
x cannot equal 3/5, which means that my vertical asymptote is x equals 3/5. Horizontal asymptote.
Wait.
Oh, that should be vertical.
Wait.
Hold up.
I was waiting to see if anybody noticed.
Hold up.
Nick's brain almost exploded. I don't even want to know what the other conversation was. Horizontal asymptote. Y equals 2/5.
Now you got this.
Thanks.
I got it.
F of 0, 2 times 0 over 5 times 0 minus 3, that's going to be 0. So that's going to be a y-intercept of the origin. Ooh, that one's going to be a tight one.
Yeah.
Okay. X-intercept is also the origin. Plugging in some points on this side, let's go with -1, -2 over, so that's -1, or to be positive 1/4. So that's going to be up in there. So that side is going to come in nice and tight like that. Then over here, no, I actually had 2. I had 2 on that side.
So you have to have at least 2.
You gotta have at least 2. Yep. Because I had the x and y intercept on that side.
That makes sense.
Okay. So over here, I can do 1, 2 over 2 is 1, 10, 20 over 47 is going to be up in there. Yeah, buddy? Okay.
Yo.
Have a great day.